Presidency. Thank you very much for the invitation. And now I will turn to glucose and vitamin C, although I am not speaking about the food. I will speak about the energy and the importance of these two things in the energy of our cells. First of all, I would like to introduce myself. I'm a dermatologist and immunologist, and we do have many cancer patients, as we have many patients with melanoma malignum, and we have also with planocellular carcinoma, basocellular carcinoma. So therefore, we are dealing mainly with the sunshine and then with the environmental factors and not so much about the food. Therefore, it was very interesting for me and very, very important for me to hear these excellent lectures, what we could all follow today. Now I would like to turn to my lecture. I will speak about the high-dose vitamin C treatment for cancer. Afterwards, I will speak about the energetics of eukaryotic cells, and as the final point, I will speak about the actions way of high-dose vitamin C treatment of cancer. So, first of all, I was dealing with the high-dose vitamin C cancer treatment, and in that time, it was about 6 or 7 years ago when I started it. I wrote the paper from Cameron and Pauling, who was telling us that supplemental ascorbat in the supportive treatment of cancer prolong the survival times in terminal human cancer. This was in 76. Some years later, Cregan and Mortel published the contra opinion. They said that the failure of high-dose vitamin C with advanced cancer patients. The problem was that Cameron was publishing that it was a match-controlled study, while Mortel and his co-workers said that their study was randomized, double-blind study. So therefore, the science showed that Mortel and his group has the right. And it was a big debate between the two scientists for several years. As Pauling is a Nobel Prize winner, and therefore they said that he is belonging to the silly Nobel Prize winners because it is not true what he said. But finally, some years later, it turned out that it is still true what Pauling said, because it turned out that if you are giving the vitamin C intravenously, it is completely different from that if you are giving it per dose. And Cregan and Mortel give the high-dose vitamin C per dose, while Pauling and his group gave it sometimes per dose, but mainly intravenously. And if you give it intravenously, then about 200 times higher blood level can be reached compared to the per dose. Therefore, it is a really important thing that how it is given to the patient. Afterwards, I was reading over the different publications. There are many publications regarding to this field, and I was collecting the data from 20 publications, and from that I get the conclusion that a remarkable clinical regression was published in 9 papers. The result was questionable in 2 papers. papers, and no clinical results was detected in 9 papers. So I was wondering, how is it possible that so many people are doing it and so different will be the result? And I got the idea that something is wrong with glucose and with vitamin C. For instance, those who are telling that remarkable clinical regression is detected, one publication is belonging to those who were writing that ketogenic diet and vitamin C together is excellent. And in the contrast, if you are giving the intravenous vitamin C in dextrose-containing fluid, then the result will be nothing. So I thought that glucose can stop the reaction of the vitamin C. Based on that, I started to develop my way of thinking was developed by these 2 things. If I summarize this, what I was telling till now, the results of murine experiments and in vitro results are telling us consequently that a vitamin C is killing tumor cell, although the clinical results are contradictory. Based on that, I was developing the energetics of eukaryotic cells, and I will publish it soon, and I would like to summarize the background of this for you. First of all, I would like to speak about eukaryote cells, about the energy transformation, the structures for energy transformation, and the determining components of these structures, what I was developed. The eukaryotic cells, they have peroxisomes and mitochondrion. The important thing is that at the beginning, when the life started, in the air there was no oxygen at all. At that time, the cells were already created, but afterwards oxygen appeared in the air, and this oxygen killed everything because the cells were not prepared for the danger of the oxygen. And one of the cells escaped this problem, namely mitochondrium, developed the possibility to fight against free radicals, and an old cell and the mitochondrium went to symbiosis, and they created the eukaryotic cells. So therefore, I think it is important to realize that in the eukaryotic cells we have not only the mitochondrium, but we have also the old structure of the energy transformation, which is in the peroxisomes. The eukaryotic cells therefore have 2 types of genetic materials. It is coming from both cells, and they have 2 types of energy transformation structures. One is called energy transformation structure of aerobe glycolysis, and the other is for oxidative phosphorylation. This oxidative phosphorylation is coming from the pyruvate dehydrogenase, which is present in the mitochondrium. And it is also very important that the mitochondrium helps the survival of the ancient cell and fight against free radicals. So if the mitochondrium is not working because of missing oxygen, then this defense against the free radical is also missing. It's very important because in tumor cells, the mitochondrium is not working. and therefore it is targeted by free radicals, and therefore it will be sensitive for irradiation. Although the other cells where the mitochondrium is working, they are not sensitive for the radiation. What I mean about energy transformation. If we think about the fact that the car is not able to use the aired oil because its energy is the petrol or the diesel fuel, and the car is not able to work with the aired oil. I guess the situation is very similar to the cells and the glucose. I think that the cells are creating adenosine triphosphate from the glucose, and during that time energy will be liberalized also, just like in the aired process. And this ATP will be the real energy source of the cells. The background of this energy production is because of the molecules, which are atoms, which are responsible for the electron transfer, for the development of the electron transfer. To understand this, we must realize that in oxygen and in sulfur, in the electron path, in the outer electron path, we have 6 electrons. The other important thing is that the iron has 26 electrons, but there are 2 types of them, when in one only 24, in the other 23 electrons are available, and therefore we have iron 2 plus and iron 3 plus, and this is very important that the iron 2 plus and 3 plus are different in the bonding oxygen or sulfur, and if you change the nature of the iron from 2 to 3, then the iron will like oxygen instead of sulfur, and this helps the electron transfer for the development of the electron transfer. Leroy Wiecka and his colleagues were published that the vitamin C is able to change the iron nature, and it will create iron 2 plus from the iron 3 plus, and therefore the iron sulfur cluster, which contains sulfur, will change the sulfur for oxygen containing molecules as H2PO and O uric acid and aminated uric acid. And finally, when the process is going on, from these molecules we will get PO3 and aminated uric acid, and afterwards the sulfur will go to the place where the oxygen was previously, and the oxygen was what was there previously. It will create CO2 in the activity. The change of oxygen and sulfur, this will result a switch on and switch off of the structure, and this will result finally ATP, pyruvate, and acetic acids. It's important to know that there is an electron transfer chain which is suggested by Austin et al., and they were publishing this, what I show you, and I suggest that instead of the 4 iron 4 sulfur, we have another type of structure. Namely, I guess that in the electron transfer chain we have 3 iron 4 sulfur, 1 4 iron 4 sulfur clusters. Then we have 4 clusters which are 2 iron 2 sulfur clusters, and we have 4 8 iron 7 sulfur clusters, and they will create the electron transfer chain instead of the 6 4s clusters. The important thing is that all clusters are connected to each other with the cysteine parts, and the cysteine parts have 2 places, one nitrogen which is able to bond vitamin C, glucose and acetic acid, and the other one is an oxygen which is able to bind the ATP. So therefore, these are able to create a complete electron transfer chain, and this electron transfer chain, as I told you, is connected with each other by the cysteine part of the molecules. From this electron transfer chain we have 2, and these 2 will be connected with each other by vitamin C. And it works in the way that in one of them we have activity while the other is in the rest, and afterwards the other will be active and the first will be in the rest situation. Therefore, we have a situation when the 2 electron transfer chains are mutually activating the neighbor, and in that way we have a so-called perpetuum mobile, which is working for every time during our life, and it is responsible for the energy making in the cells. In the set of oxidative phosphorylation, we have this multiplex electron transfer chain, and we have the pyruvate dehydrogenase, and we have ATP synthetase, and they are responsible for the production of new ATP and 36 CO2. The results of energy transformation will be in the set AG 24 CO2 and energy, and if you are looking to the set OP, oxidative phosphorylation, there we have 12 more CO2 and a much higher energy amount. I guess this is the background of my way of thinking. So if we summarize what I was telling, the glucose and the vitamin C are needed for energy transformation, and the cells will die if the vitamin C starts the reaction and the glucose is not present in the cell. That's because of the fact that if you don't have the sugar, the glucose, then you are not able to create the 5 carbon containing sugar, and therefore the oxygen which should oxidize the 6 carbon of the sugar, it will kill the cell. So therefore it is important that at the time when you are treating the patient with high dose vitamin C, you must be careful that the patient is not allowed to eat sugar or drink sugar, otherwise the result will be not detected. The mitotic cells are the real targets because the activity of them is much higher than the not mitotic cells, and in the cancer cell about 200 times more glucose is detectable than in the normal cells because of the Warburg effect, and therefore they will be the target for the vitamin C, and therefore they will kill the mitotic tumor cells, but they don't kill the other cells. So therefore, alone the vitamin C treatment is not enough. You must give good treatments, and if you give to that the vitamin C, you will have a good and better result, because if you are killing one part of the cells and the immune cell will have to kill less than previously, then the result will be better. So that's what I wanted to tell you. I hope that it was interesting, and thank you very much for the possibility that I was able to tell you.